really obvious, I have to say the word population, or I have to say the standard deviation for all geese was 2.9 inches.
So we're taking number 1 for all air quality of the U.S.
No, the following are air quality measurements over the past 15 days. So that's a sampling of air quality measurements.
Right.
Yeah.
So you put all of them.
So if you can't tell, you assume it's a sample because it probably is. What do we normally work with in statistics? A sample. If I have a population, I want everybody to know, hey, guess what? I got a population, you know, and then, like only stats people would be excited about. I got a population. All right, that's good for you. Yes.
The one of class 3, so you said we should use only 5 or 6, right?
Yeah, for our size samples, 5 or 6 normally. Yeah. I'm not going to give you, thank God I'm not going to give you enough data points that you would have to use 8 or 9 or 10. That would be a lot. That would be a huge sample. I'm not going to do that to you. I look at people and your eyes going.
Can you do a 1.4 number 88?
Oh, okay. This is the one, everybody should know this one, the Acme and the other guys, the graphs. The main thing that I must see said at some point in whatever you say about that, who knows? It's the fact that the graphs they gave me, who remembers this? The Acme graph and the other guy's graph, and it shows Acme is like going way up. Whee, look at us, we're better. There's no frickin' scale at all. Right? So the other guys could be like doing way better. So Acme could be 1, 2, 3, 4, that scale, and the other guys could be 10, 20, 30, 40. And then we look at us, we're crazy good. No, you just picked a scale. Huh? Screw you guys. And it seems silly, but there have been instances where people have discovered companies doing exactly this. They have something without a scale, or the scale is kind of like shifty or whatever. And then it just kind of gets forgotten. And it's like, oh my God, because people don't understand statistics. They're like, oh, I have some weird data. I love that company. That's some weird data shit you're talking about. Look what they did. Look what they did. This is bullshit. But people don't understand what it is. So they're like, oh, whatever. But it happens. And why does it happen? Because companies know, people don't know. People don't know to look at that. Yeah.
Didn't they just like took a portion of the total graph, so it looks like it's just...
Yeah, it's weird because they look the same for a while, and it looks like they zoomed in on half of it or something weird. Yeah, so you could even say something like that. But the main thing is the fact that there's no scale on either axis. I have no idea how to compare them then. I can't compare them. Yeah?
Could you do 1B and C? Could you go with that?
So 1B is where you get the class width, right?
Which you choose, right?
You choose the number of classes, but then you show me the work. High minus low divided by that. So it's always going to be divided by 5 or 6 for you guys. We're not going to have a big enough sample for something bigger. And then you start at the lowest one, and you just start to build off of that. And let me just tell you this. I mean, I told you this last time, but to make it easier for yourselves, let's say I had data that went from 42 up to 99. And I want to use 5 classes. So how would I figure out the width?
Subtract 42 from 99 and then divide by 5.
Alright, so what do you get there? 57 divided by 5 is 11 point something, so I'm going to round up. Always round up. Some poor person got like 6.5 and used 6.5. Don't do that to yourself. Round up. Right? So what am I first? So I'd say 42 less or equal to x less or equal to 54. And next to it, just like I told you, this is the only good thing about this. Write like this so that you know what data points to actually count. Because most of you guys, actually, I did that wrong. Most of you guys are okay with this, it seems. But some of you guys are double counting some of these because I understand why you do that. But why is this better? Because when I make the scale, there's no gaps. 54 goes right on top of 54. But next to it, I can have, so this one actually goes from 54 up to 65. So I can look at this to know what to count in each. Because that seems to throw some of us off sometimes. I don't know if that makes any sense. I only had one person that, I'm not picking on anybody because I'm not telling your name because I forgot. They put 12 everywhere. And where do you think they got 12 from? Because these are 12 apart. Don't laugh. I understand this. This is weird when you first do this. But what I'm putting here for frequency is not how many numbers, like there's 42, 43, 40. It's how many actual data points, right? So if there's 42, 42, 47, 53, 57, then how many data points? 1, 2, 3, 4. So there would be a 4 there. It's a number of data points that actually fall in there. Not the number of values that could be in there, right? Because then everything in the world would be. Let me see the numbers, Johnson. Looks just like the other. It's like, no, I need some variation. Okay, maybe yes.
Can you do G of 1? Kind of forget.
Oh, all right. Well, so let's see. Let me cheat a little bit. I got this in order here.
I'd like to do F too, so I don't want to do
F.
Yeah, well.
Oh, okay, good. I like it. Let's do F real quick. So, assuming we already did the work, we know the mean is 45.667, right? So just looking at, if you haven't done it yet, it's on the key here. And the standard deviation, I worked it out to be, where is it, Jeff? You can do it. There it is, dude, 8.575. Cool? Yes, sir.
Could you just use that one rule saying within one standard deviation for that 68% without even working it out? Could you just
What is that true for? What's that only true for? Empirical rule only works for what kind of distribution? Normal. Do I know this is normal? No. I know it's roughly normal. I wrote that because once you do the histogram, it looks roughly normal, but then the rule doesn't exactly apply then. And this question is what is exactly between, and not theoretically what would be between, right? So you can't even use chubby dude and say, what did I say, within 1? So don't. If I say within 1, don't say at least 0%. Well, that's true, but I want to know exactly what percent. And the reason I do that is because we have these theories about how much data should be where. I want a concrete problem to actually look to see how much frickin' data is there, to see if the theories are right? So I think this is normal. This is kind of neat. If I think this is normal, I can check. Does it have roughly 68% within one standard deviation? Does it have roughly 95%? If it does, it's more verification that maybe this is normal. So what do I put right in the middle? Yeah, 45.667. And I go up and down one step. So I'm going to add 8.575 and subtract 8.575. So where do I end up? Add 8.575, I end up at 54.2 something. Yeah. Is that cool?
Yeah.
If I subtract 8.575, I end up at 37.1 something. So which data values are in there? What's the... So like 37, would it be in here? No. So it starts at 38. Do we have a 38? Yes, we have a 38. I don't know if I want to. So we have 38, we have a 40. Is this cool? We have a 42 or 44. 45, 45, 47, 48, 50, 52, 53, and that's it, right? Because 55 is out of there. So what percentage of the data is in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 divided by 15. Yep. 11 out of 15 of the data points are in there, so that's going to be the percentage of the data that's in there. So I get 73.3. I can almost read my own writing. Oh, yeah, I almost had to retire there. If I can't read my own writing, I have to retire. What's that not quite close to, really? 68. So I'd say, well, maybe this isn't quite normal, right? If it was normal, it should be 68%. But one reason I do the concrete calculation is to see how close to normal it looks like it might be. It's a really small set of data, though. But this is the analysis I would do on a large set of data. It would mean more with a larger set of data. Technically, I can make a set of data where I do all this work and there's 0 in there, right? That's what Chubby Dude said. You can make a set of data so that there's nothing in the first standard deviation. Oh, I'm sorry. Did I do it? 1G. All right, so let's look at 1G. What's the 5 number summary?
The box low, 1, 2, 3.
Yeah, so low, Q1, Q2, Q3. So the low and the high, I got no work to do. How do I do the work for Q1?
25%.
Yeah, 25% of what? 15. So that's step 1. 25% of 15 is 3.75. It comes out to not a whole number. I just round it up and then take that number. So the 4th number will be the answer. 4th number is the answer. What is the 4th number?
40.
1, 2, 3, 4. Yeah, 40. I like it. Is that cool? And then you just keep doing it. Just keep doing that same thing for Q2, Q3. Do the same thing again. And if you you're going to have all this data in your calculator. If you do one variable statistics, one variable, whatever, then the last 5 things it tells you are the 5 number summary. You can check your work. You can't just say, I pushed this button. Even after I've said that, I've had somebody said, I pushed this button and got it from there. That's showing you my work. That's what my last teacher said. I'm not your last teacher. Yeah.
And for Q3, if we just counted 4 from the back, that'd be fine.
I love it. Kick ass. So if you're smart about it, the more you know, the less you got to do. So if you understand Q3 is going to be the same distance in from the top as that was from the bottom, do that. That kicks ass. If you don't know what the hell I just said, take 75% of 15, just do the work. You don't have to do shortcuts, but they are nice.
What you said, here, the 4th number is 44.
Say again, sorry?
The 4th number is 44, not 40.
The 4th number,
You have to
Yeah,
4th number is 44?
yeah.
No, it's not.
If you have to organize it.
Oh, you're looking at, so medians and Q1s, they only make sense if it's in order. If they could be any order, then they could be anything. Why would they exist? So it's if it's in order. Yeah, it's all about being in order. Thank you. Yes?
I have a question. I'm kind of confused, like the difference between statistic and parameter. So the researchers find that the percentage of stomach cancer occurrences in the sample was 4%. Is that a statistic or a parameter? I put statistic, but didn't you say parameter is like the average or the percentage?
Of a what? That's the key. They're both average or percentage. Statistic, parameter, they're both an average or a percentage. What differentiates them is what they're talking about. A parameter talks about a population. Parameter talks about population. A statistic talks about a sample. You gotta love when that happens. It just sort of randomly happened. The word we use for what describes a population starts with the letter P, and the other one starts with the letter S. Kicks ass.
Okay.
So since I was talking about a sample there, right?
Yeah.
It's a statistic. That's why.
Okay.
Not because it's a number, not because whatever. It's because it's a numerical description of a sample.
What determines the normal curve? Like earlier, there was the one thing that you were using, and it looks like it could be very similar to a normal curve. So how do you?
Right now in this class, we only have an objective by sight. If I do a histogram, does it go up and then come back down? You kind of with me?
Right.
They're very objective, or subjective, sorry. very subjective. I mean, so somebody else could think that it's not, and you could think it is. So you could say it's roughly normal. So I said this one was roughly normal because it does go up and come back down, but I mean, this bar here is too high for it to really, it's just too damn high.
Right.
It should be lower for it to be really symmetric, right? It's roughly normal because it does look more normal than it could. You see what I'm saying? But later, it's going to become very important. If we know it's normal, we know a lot of shit about it. That's awesome. So later, we're going to start to develop methods to test normality. Because if we know it's normal, then I can do a lot more with it.
Right, but so if we don't know that it's normal, are you going to tell us it's normal if we need to use this information?
Yeah, if you need to use empirical rule, I have to tell you it's normal.
All right.
Yeah. I don't think I had a situation on here where that happened. I didn't put anything on here about empirical, did I?
No, not on the
Shoot. So like on number 2, that would be a place I would put something about empirical. I'd say something like, if we knew that the textbook's price was normally distributed, between what two values would we find 68% of the textbook prices. So you have to go one step up and one step down. Yeah. Then you could use empirical rule because I told you it was normally distributed. Good, I like it. All right, let me just say this. If you're ready for the test, you don't have to sit there staring at me. Yes, ma'am.
Number 3 on the practice test, if we put 3 standard deviations instead of 2.92, would that be acceptable or no?
No, z-scores are going to find out z-scores we want to go to a couple places. Because later we're going to use a chart where the z-scores go to a couple places. But I didn't really specify here. But always show your work before you round, and then you cover your ass for right now. Yeah. Sure. Yeah. Okay. Oh, the second quiz. Yeah. Yep. That's fine. It'll be on time. Sure. Okay. No. Yeah, I love you. You're always like, is this too much? There were only 4 problems on here. They were each worth 20-something points. Yeah. So I was considering, well, it was this and this together with 7. I think that was -4, and then issues with the scales was -5. So I took off 7 total. Yeah.
I make corrections. Can I have you look at it?
Okay.
I'll bring the correction.